Hello, everyone. Good morning, everyone. I'm Quan Quan from Reliable Flight Control Group in Beihang University. It's a pleasure to come here again to share what we have done in the past year. Today, I will share how to develop the more full-stack multicopter engineering, model-based design with MATLAB and the Cube. 大家好，我是来自北航的全全，很高兴再次来到这个地方跟大家分享一下我们过去一年做的事情。那么今天我将分享的话是如何去培养那个更多的全站式工程师。Reliable Flight Control Group aims at developing evaluation and control methods to make flight reliable. 我们的实验室是力图是培养是设计、评估和控制算法，是使得飞行更加的可靠。In a traditional way, a chief engineer may lead many engineers to finish a big project, such as full-size airplane or fighter. In this big company or institutes, there is no lack of engineers, financial support, experience, resource. However, today, many small companies have few engineers, less experience, few resources. Several engineers have to take charge of the full life of a multicopter design. So full-stack multicopter engineers are needed urgently, in my opinion. On the other hand, as the task and the human costs are both increased today, more and more, big companies or institutes will also need full-stack engineers urgently as well. 因为对于传统的方式的话，总师的话，通常是领导很多工程师共同来开发一个任务。对这些大的公司或者企业来说，研究所来说，没有很少出现工程师财政啊或者经验一些资源的问题。但对于小微企业的话，他们只有很少的工程师、很少的经验和很少的资源，所以呢，对于他们来说更需要全站式工程师。从另外一方面来讲的话，到目前为止的话，即使对于大的企业、大的这个研究所，据我所知的话，他们的任务越来越多，人力成本越来越高，同样他们也需要更多的这种全站式工程师。What is a full-stack multicopter engineering? A full-stack multicopter engineer has a functional knowledge of all technology, languages, and system engineering concepts required in multicopter development. 对于一个全站式工程师，他需要掌握各种各样的知识、语言以及系统知识，去帮助他们开发整个的这个多旋翼飞行器。So for such a purpose, we wrote a book, Introduction to Multicopter Design and Control, published in 2017. And we also opened the course online in China as well. In this book, we introduce airframe configuration, propulsion system, modeling, calibration, state estimation, control design, planning design, and fail-safe design. I think this have carved the theory a full-stack multicopter engineer needs. Surely it's not enough for a full-stack multicopter engineer if without practice. In my opinion, full-stack multicopter engineers have to know developing tools, operating the system, coding, software testing, flight testing, and so on. How we do it? The answer for me is develop new tool plus new course. So we hope, based on the new tool plus new course, I hope that people with background of electronic engineer become chief engineers. The new tool is based on Cube or Pixhawk, which is the most widely used autopilot hardware. I come here for advertisement for her thing. And MATLAB is the most widely used language in engineering, one of the most. Multicopter, the most widely used small aircraft. We use model-based design to combine them together. Let's watch a video to learn about this process. In fact, I have showed this
In this video, we want to introduce a development and teaching platform based on model-based design with MATLAB and PyXHawk. The platform aims to make it easier and faster for students and engineers to realize their control algorithms on real multicopters. The whole platform consists of 4 parts: the controller design and simulation system, the PyXHawk autopilot system, the hardware-in-the-loop simulation and testing system, and instructional materials include textbook, videos, and demos. For the model-based design, an accurate model is required basically. The platform provides a high-fidelity multicopter model in Simulink. The model parameters can be precisely obtained by the following procedures. First, the propulsion system parameters can be measured by the professional equipment as presented in the video. Secondly, the physical parameters like the mass and moment of inertia are also measured according to the existing methods. Thirdly, the aerodynamic parameters are measured by CFD simulations along with system identification methods in flight tests. Based on the obtained model and parameters, the whole development process includes 4 phases: the software simulation, automatic code generation, hardware-in-the-loop simulation, and flight test. In the software simulation phase, users can design and simulate controllers in Simulink and observe the flight performance in flight gear. Then, the following teacher functions can be achieved. The second phase is automatic code generation. After designing and verifying the control algorithm in Simulink, users can simply click the compile button. Then, the Simulink will generate the code and firmware, along with the related documents and reports. Then we can download the firmware into PyXHawk Autopilot, and the Autopilot will run the designed algorithm after restart. The teaching functions include learning the model-based design method and generating the code, firmware, and documents for practice. The third phase is the hardware-in-the-loop simulation. We provide a Windows version Hill simulation system for the PyXHawk Autopilot. The model and parameters come from the previous Simulink model. The Hill system communicates with the Autopilot through a USB cable. Then it simulates the multicopter flight dynamic and sends sensor data to the Autopilot. The Autopilot calculates control signals and return to Hill system to close the loop. The Hill system can also connect to ground stations to simulate an autonomous flight mission. In this system, the following teaching functions can be achieved. After passing the Hill simulation, we can perform outdoor flight tests by assembling the Autopilot to a multicopter with the same parameters as above simulations, so that the designed controller can be realized and verified through real experiments. The teaching functions include comparing the real performance with the simulation results to further improve the model and control algorithm. The following courses can be opened on the teaching platform: Propulsion System.
OK， 我用中文讲一下前面讲的事情，就是因为我们在17年的时候、18年的时候推出了这个多旋翼方面的这个书，但我觉得那只是关于理论方面的一些书籍，所以在近2年我们开发了这个实践的一个系统，就希望从理论到实践，那么希望培养更多的，如果以电子工程为背景的这个工程师到成为全站式工程师。刚才那个视频的话， 主要讲了一下这个我们整个的开发的整个过程，有中英文的这个解释。In a word, the three steps are performed, namely software in the loop simulation, hardware, software in the loop simulation, and the flight test. By this method, we can design and also test in different phases. This will speed up our design process. Many problems can solved in the simulation phase. Just now, Peter mentioned auto test is an impressive function, I think. Then after this phase, we can perform the flight test. If we find the results are inconsistent between simulation and actual flight, then we can improve the model. That's a key point. We improve the model. 就总的说来的话，我们整个的话就分为3个阶段，软件仿真阶段、硬件仿真阶段，加上实际飞行。那么我们希望把大部分问题在仿真阶段把它解决掉，最后再进行实际飞行。如果我们发现仿真跟实际飞行不同的话，我们会去修改模型，这是我们的那个。What's more, swarm hardware in the loop simulation also perform based on the platform we designed. Let's watch a video to learn about this. We have 3 qubits and open 3 qubits around the flight control algorithm on them. Then open 3 CubePilot software. The 3 CubePilot software runs the model of the multicopters. So we can combine together. We have downloaded the code into the cubes. So 3 multicopters clamps up and have a formation at the beginning. We can adjust the velocity for them. The 3 multicopters climb up. We zoom in so that we can observe them easily. We can change the model. We can change the model so that the 3 multicopter can have different formation. So we change to another model. And notice that the 3 multicopter communicate with each other. So we can perform distributed control method on this platform. We have booths behind the hall. You can communicate with our students face to face. Our student can carry out this simulation for you. Okay. Sorry. Because this PPT have many videos, so it's. So based on the platform just mentioned, we designed 8 tasks. They include propulsion system design, dynamic modeling, sensor calibration, state estimation, filter design, attitude control design, fixed point control design, semi-autonomous control design, and fail-safe logic design. I think they have covered the theory. A full-stack and multicopter engineer needs basically. 刚才的那个视频呢是关于集群方面的视频，待会儿大家可以有空的话去后面的讲台跟我们的学生面对面的交流。那么我们 整个的这个设计的话，我们其实包含了8个大的实验，动力系统设计实验、动态建模，然后传感器、标定、滤波器设计、状态估计、姿态控制、位置控制，还有半自主飞行控制以及失效保护等等这些方面。We have 3 rules, starting rules in the following. The classic route is from design and modeling experiment to control experiment. You should notice that modeling in experiment 2 is based on the propulsion system design in experiment 1. Attitude control design in experiment 5 is based on modeling in experiment 2. Position control design in experiment 6 is based on modeling attitude control in experiment 5. Just one route. A hard route is from design and modeling experiment to control experiment, then to decision making experiment. Semi-autonomous logic design in experiment 7 is based on experiment 5 and 6. Fail-safe logic in experiment 8 is based on experiment 7. The challenge route has estimation experiment additionally. So it is a whole, one based on the former experience, so that the readers can do it step by step. Take experiment 1, for example. After reader complete experiment 1, they will have 4 components of design propulsion system. Then tap them in our website, flyeua.com. Readers can obtain the modeling parameters. These parameters can be used for modeling experiment. 就刚才介绍的整个的这个实验的话，我们有3条路线。最经典的路线是从建模，从设计建模到控制。第2条路线比较艰难一点，多了一个决策。第3条路线呢是最有挑战性的，增加了滤波。那么我们整个的实验是，下一个实验是基于上一个实验，所以我们一步一步完成的。那么我们以第一个实验为例的话，我们第一个实验是一个设计实验。其实是告诉大家怎么样设计一架飞行器出来，然后你这样的话你得到了很多元器件。那通过我们的网站 flyeua.com 的话，你可以得到建模所需要的参数。In fact, each experiment has 3 step-by-step experiments for readers. Namely basic experiment, analysis experiment, and design experiment. First, in each step experiment, we follow the model-based design. 我们整个这个实验的话，每个实验其实都有基础实验、分析实验和设计实验。那每个实验里面又有软件仿真和硬件仿真。我们每个小的实验都会按照那个基于模型的开发的思路来进行的。You will ask me, what is basic experiment? Basic experiment. In this experiment, readers will open the given code example, then read and run the source code directly to observe and record the results. This helps readers to be familiar with the platform. In analysis experiment, readers will modify the given code example so that can run the modified example program to correct and analyze the data. This helps readers to familiar with the algorithm. Based on the above 2 experiments, readers will complete the given design task independently in the design experiment。那大家可能问为什么还有基础分析和设计实验？那基础实验其实是帮大家复现就可以了，直接跑一趟代码，你就可以得到你想要的结果。这主要帮助你去了解我们整个平台。那分析实验的话，那你去做小修小改，这样的话呢，你可以对我们相关的算法更加了解。那基于这个2个实验呢，你最后来实现你的设计实验。这个设计实验是要你独立进行完成的啊，因为我们其实碰到很多学生，他是从不同的这个背景，所以我们需要这三个实验。Why we designed 3 experiments? That's because I encounter different students with different background. Some students don't have the background of MATLAB, so this motivate me to design the 3 experiment step by step to help them to know about whole of this. Take experiment 5 for example. We base the things to prepare. This is the objective. Repeat, record, perform, something blah 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 like this. As for the analysis experiment, adjust the PID controller parameters to blah 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 using the satisfied parameters to get the border plot blah blah blah. This is the analysis experiment. And for design experiment, we will ask readers to finish all of this. 对于我们刚才的那个基础实验的话，我们是拿我们的姿态控制实验作为例子。我们的基础实验是就是复现就可以了。分析实验你可以看到我们要调节 PID 参数等等，对吧？然后用我们的参数去得到一些博德图。那我们的最后的这个设计实验的话，我们要求我们的读者的话去完成这些指标，对吧？This is very suited for the students in college, I think, because they have to learn automatic control about this. 这非常适合我们的这个在学的那个学生。We have finished all design with code for these 8 tasks. All codes are implemented not only in simulation, but also in real flight test. The left video is about the semi-autonomous logic design. The right video is to show the fail-safe. We download the code into Cube and perform the actual flight test in our university to test whether it achieves the requirement. 我们所有的代码我们都经过测试，我们做了仿真，不仅做了仿真，我们还做了相应的实验。那么这边的话是就是手动控制的实验，我们有3个模态定点、定高和姿态控制模式。那右边的这个是失效保护We turn off the power of the transmitter, so we see the multicopter if the multicopter can respond correctly. from this table, you can learn about the objective and what will be done in the step experiments. Okay, as a teacher, I'm a teacher in university. We don't want 2 students have same tasks, you know. So in order to avoid predicting, I think we have 2 solutions to solve this problem. The first solution is modify the goals in propulsion system design and modeling experiment so that students will have different model and different models. With the different models, they have different controller. With different controllers, they will have different logic design. This is one thing. On the other hand, to satisfy some students with strong ability, the most difficult process starting route can be assigned to them. Also, we can add some experiment additionally, open some new experiment for them, so that they can obtain extra score. 对于一个老师来说的话，我们不希望两个同学有同样的任务，这样的话他们会，对吧？互相抄袭啊。所以呢，我们有2种方法来解决这个问题。第一个方法的话，我们会去改变我们的这个设计实验和建模方面的实验，我们可以让他们做不同的飞行器。这样的话，他们有不同的模型，他们就会设计不同的控制器，有不同控制器，他们就要调节设计不同的这个逻辑方面的事情。那另外一方面的话是增加一些新的一些实验，对于能力强的同学来说的话，去增加新的实验，这样的话可以让他们走最有挑战性的路线，增加一些实验。For example, they can perform predictive control, some new control method on our platform. 所以他们可以去比如说设计像预测控制这样的控制方法，去在我们的平台上面。Okay, let me draw a conclusion with question sheet. 10 questions help teaching assistant to evaluate a student. From question 1 to question 7, the first 7 questions are about the course itself. As full-stack multicopter engineer should reply these questions in my course. From question 8 to question 9, a full-stack multicopter engineer should extend the applications based on the offered platform. From question 10, I think a full-stack multicopter engineer should know how to lead a group and organize them in a parallel way. 我们最后以一个这个问题表单来结束我的这个演讲。10个问题，这前7个的话是关于我们实验本身，对吧？我觉得一个全站式多旋翼的工程师应该回答这些问题。第8个到第9个的话是需要我们的全站式工程师知道如何去扩展应用。第10个问题，作为一个全站式工程师，应该知道怎么样去领导一个团队和组织他们，当然是以一种并行的方式，这样的话最有效率去组织他们。As for question 10, based on the platform, the designer can update each module and perform the module tests separately. For example, decision making, position control, attitude control, model estimation. Then perform the software in the loop simulation, hardware in the loop simulation, flight test, and so on. It's just to establish a database to make the testing. Just now Peter mentioned auto test. Yes, it's an impressive function. So that they can test the code separately, and I hope the code can be tested as sufficiently as possible in advance. The period of the urban air mobile is coming close. Let's watch a video.
Safe. We are working collaboratively with cities and regulators to integrate air taxis into existing environments and airspace rules with minimal impact, while at the same time developing more intelligent, autonomous, and decentralized air traffic management solutions that can safely and efficiently accommodate all types of vehicles in the same airspace. We were born to move, travel, and explore. Urban air mobility is all about giving ourselves.
刚才由于没有翻译，所以老师一下就过去了哈。就我们的10个问题的话，是帮助我们的助教去评判我们的学生。前7个呢是关于我们的这个本身这个课程的本身，然后第8个、第9个希望我们的同学真正的这个全站式工程师能够去扩展应用。第10个的话是作为一个领导，他能够领导一个团队以并行的方式去做事情。那对第10个的这个问题的话，刚才那个框图其实解释这个问题。其实我们的这个平台是可以提供这样的一个需求的啊，它可以每个模块可以不断的都可以被替换，然后我们希望建立整个的一个数据库，就刚才那 Peter 说的那个 auto test 一样，可以不断的去测试。这样的话，我们就知道我写的这个代码，我写的这一块小代码到底有什么问题，对吧？那刚才这个视频的话是关于城市交通它是一个非常就是离我们越来越近了。eVTOL aircraft or flying cars are a big opportunity today. Many bigger companies have launched their plans. So I think full-stack multicopter engineers are needed more and more. Thank you very much. Finally, we summarize the course in the slide in our book. The book will come to market, I think, in the next year, at the beginning of next year. If you want to take a look, we have some books, both in Chinese and English, in our booth. You can take a look. We hope through this book, we can develop more and more full-stack multicopter engineers for the world. Thank you very much again.